We're going to install TeraFlex's new full float axle conversion kit. This all-inclusive kit will bring an end to front driveline failures due to high-speed freeway driving, increase your gas mileage, end front driveline vibrations, and rear axle bending with the associated brake squeak. The list goes on. I'm going to assume you can figure out how to take your tires and wheels off. Roll them out of the way. You won't be reinstalling those wimpy 5-lug wheels again. We're going to be crossing over into grown-up land with 8 on 6.5 bolt pattern wheels. As luck would have it, JKs have a convenient drain plug in the housing. Save yourself a big mess. Use a 3/8 ratchet and remove the plug and drain the gear oil. You've been needing to do it anyway. Remove one side of the steering linkage and drag link. This will make life a lot easier when you turn the knuckles to remove the wheel bearings and brakes. Use a 21mm, but don't completely remove the nuts. The nuts will protect the threads and keep the tie rod linkage from dropping and causing bodily harm. With the drag link and the tie rod removed from the right or passenger side, tie the linkage up out of the way. If you're working on a Jeep with stock brakes, it's a little easier to remove the caliper first, then the anchor bracket. You'll need to replace that anchor bracket with the new bracket in the kit. The 8-lug rotors are the same dimensions as our oversized big rotor kit and require that new anchor bracket. Now, Joe's Jeep already has a TeraFlex big rotor kit on it, because Joe gets everything he wants. So we're going to remove the caliper and anchor bracket as an assembly. Use a 21mm on the large anchor bracket bolts and tie it up out of the way. It's a bonus with the full float kit. You get a big rotor kit as part of the package. And remove the rotor. Remove the 36mm axle nut. This is a good time to make sure that the axle splines aren't rusted into the wheel bearing. With the tie rod out of the way, it makes it easy to turn the knuckle and gain access to the 3 13mm 12-point unit bearing bolts. Loosen them up just enough to allow some movement, but so that there's still enough thread engagement that we can use the bolts as a wheel puller. By tapping on the end of the bolts, this will break loose the unit bearing. We won't remove it completely yet, but having it loose will make wheel speed sensor removal damage-free and much easier. Use a 5mm Allen and remove the sensor. Turn the knuckle as needed and finish removing the 3 unit bearing bolts completely. Remove the unit bearing and leave the axle in place, if possible. Sometimes the axle will follow the unit bearing out. If you live in rust country, it could take a little tapping on the axle stub shaft to get it to separate. Carefully remove the axle shaft assembly. Be gentle. Support that inner axle shaft so that damage to the inner seal is avoided. Clamp the axle assembly in a vise and remove the C-clips from the U-joint bearing caps. I'm going to bet that you don't have a U-joint press, so we're going to do this trail style. To remove the U-joint, spread open the vise and use it to support one end of the axle flanges. A second set of hands really helps position the ears flush against the top of the vise. Use a hammer and strike the axle flange on the shoulder, away from the caps. We don't want any damage from overzealous hammering where the U-joint caps press into the axle flanges. Remove the cap, flip it over, and drive out the remaining U-joint cap. Use the same method to remove the U-joint from the inner shaft. Now, we included a new set of U-joints, so you don't need to worry about chasing down needle bearings as they hit the floor. It's best to put the caps back in the original position for installation. Installing the U-joints in this primitive manner is kind of like a juggling act. Start with one end of the U-joint sticking up out of the stub shaft yoke as far as possible. The trick is to have the U-joint cap actually start on the end of the joint so that the rollers are held in place while you tap the cap in. You should be able to easily install the C-clips into each cap. The U-joint should be easy to move if the needle bearings are in place. Use the same technique and install the U-joint into the stub shaft. If you don't have room for one of the clips, double check to see if one of those needle bearings has slipped and gone sideways on you. It can easily happen. Once the joint is fully installed, do a quick rotation of the joint. If it feels tight, go back to the vise and give it a tap or two until it frees up. Install the seals and nylon bushing washers onto the new 35 spline outer stub shaft as shown. Leave the final seal loose on the shaft. We're installing it on the shaft now to reduce the risk of damage from sliding the seal over those sharp splines while the seal is installed into the spindle. Recognizing the fact that you probably don't have a press, we installed the spindle bearing using a sacrificial socket as a press tool. Install the bearing with the open end down and the rolled edge up. The bearing needs to be installed deep enough that there is room for the spindle seal. Slide in the axle shaft assembly with the seals installed. Install the original unit bearing bolts. Install the backing plate. Pull the speed sensor cable through the backing plate and slide the new spindle onto the axle stub shaft. Tuck the seal into the spindle bearing as the spindle is being installed onto that stub shaft. Install the speed sensor into the new spindle and final tighten to 40 inch-pounds. Once all the original unit bolt bearings have been started into the new spindle, final tighten the three 13mm 12-point bolts to 75 foot-pounds. The new 8-lug hub assembly has the inner bearing, speed sensor, and tone ring pre-installed and greased. You're welcome. The inside surfaces of the hub should be coated with grease to reduce corrosion from any condensation moisture. So coat the bearing race and splines as well. The outer hub bearing is pre-packed, but feel free to wipe a little extra on it. Throw a little coating of grease on the outer seal surface of the hub where it goes into the spindle mount. Did you notice how that speed sensor tone ring is completely sealed and protected from the rocks and mud? Install the hub and bearing assembly. There is an inner nut with a small pin and a washer with holes and a final jam nut. The inner lock nut has a small locking ring indexing pin. That small pin needs to be installed to the outside so that lock ring will index on it and keep it from working loose. Here's the procedure for that inner nut preload. Run the nut in by hand and then use a hub nut socket to tighten the nut to 50 foot-pounds while rotating the hub. This is only to preseat the bearing. Now back the nut off 90 degrees or a quarter of a turn. Install the lock ring onto the nut. If the pin doesn't line up with one of the holes in the ring, flip the ring over and try again. There's an offset between the holes in the washer and the inner indexing tab that will allow some fine adjustments. If you need to adjust the inner nut for pin lineup, always go tighter. You should be able to turn the nut almost by hand for final bearing preload. With the bearing preload finalized and the lock ring in place, install the jam nut and torque it to 180 foot-pounds. In the hub box, you'll find a spacer that needs to be installed onto the stub shaft. Make it so. Next, install the spring, followed by the piece with the outer splines. As with all the hub components, coat them with a little grease. Now, this can be a bit tricky. Both the outer and inner splines need to line up as it is pushed in. If you're struggling, make sure that the spring isn't hindering the process. It will seat into the inner part of the locking assembly. The disengagement ring and the bolt ring will be installed together. The bolt ring has small threaded holes in it. The bolt ring has an out stamped onto it. Need I say more? Position the engagement ring with the ears out and the bolt ring with the out marking out, and slide them in, pushing against the spring pressure, and wind in the retaining ring. Now, there will be constant spring pressure and multiple parts that need to be held into place while you install a full circle retaining ring. You will be filled with pride as you accomplish this task. There's a snap ring that needs to be installed into the recess that is cut into the axle stub shaft. Odds are you won't be able to see that notch until you get a pry bar or a screwdriver and push the axle out. Just pry against the U-joints. Install the retaining ring by winding it into the axle stub shaft. Line up the notches or recesses in the inner section of the hub with the outer section recesses. This should correspond with the lock icon on the face of the hub. Grease the engagement ring tabs and the inside of the hub where they make contact. Install the smaller O-ring on the black engagement dial. Now, this is a tight seal, so a little grease will make engaging the hubs much easier. Assemble with the hub in the lock position. Install the large outer O-ring onto the outer bezel. This will save you fighting the spring pressure during the installation of the small bolts with copper washers. You may need to rotate the engagement ring so that the chrome bezel can be easily installed without spring pressure, and so that the small socket head bolts will line up. Use a 9/32 Allen and torque them to about 17 inch-pounds. Just good and snug. That should do it for the hub assembly. Reinstall the tie rod and drag link if you chose to follow our wise counsel and remove them. As you recall, Joe already had a big rotor kit on his Jeep, but when we were going to reinstall the caliper assembly onto his new rotor, it just didn't seem right to not install that extremely shiny bracket. So we did. Remove the caliper bolts with a 13mm and using a 15 to hold the slide pin. Re-grease all the slide pins and anti-rattle clips with high-temperature brake grease before reinstalling. You'll thank yourself later. Be sure to use thread lock on all of the caliper and anchor bracket bolts. Torque the large anchor bracket bolts to 85 foot-pounds. Reroute the speed sensor line back into its bracket, and let's move to the rear. We flip the Jeep around for your viewing pleasure. Start by draining the rear diff. While it's draining, lift one side of the axle, let it drain for a minute or so. Then lift the other side and let it drain. This will help get the residual out of the tubes. With the tires and wheels removed, start by removing the rear brake calipers. Use a 13mm and a 15mm open end to hold the pins from spinning. Hang the caliper up out of the way. Remove the anchor bracket using an 18mm. Disconnect the park brake cables. Remove the 4 brake backing plate retainer nuts using an 18mm. And remove the rotor. Carefully remove the wheel speed sensor using an 8mm. Now don't try to connect the harness from the sensor. It's a real pain and it's not necessary. You'll probably just break the thing trying. It comes out connected to the harness just fine. Flip the rotor around and loosely thread on a few lug nuts. It'll work just great as an axle puller. Use it like a slide hammer. Remove the axle and rotor as an assembly. Remove the backing plate and reach into the bearing pocket and slide out the bearing race. Clean up any residual gear oil and mentally prepare to drill a 1/2-inch hole into the axle tube. It's going to be used as a plug weld location. Push a rag or some shop towels into the axle tube just to prevent any drill shavings from entering into the differential. The hole you will be drilling really doesn't have a critical location. Just come back about 1 inch from the axle flange and make a mark on the center line of the axle on both sides of the tube. Center punch the mark and pilot drill the holes and final drill to about a 1/2-inch hole. If you have a step bit, they work amazingly well. We marked the final step on the bit so that we would know how deep to go. Add them final drilled with a 1/2-inch bit just to clean up the hole prior to welding. We're going to be installing a press fit spindle into the axle tube. If there are burrs or any shoulder on the hole that we just drilled, it can hamper our spindle install. So we cleaned up the inside of the axle tube by sliding a step bit in the inside of the tube and doing a quick ream on each side. A file will also work just fine. When you're done making metal filings, reach in and pull the shop towels out of the tube, letting it remove the filings on its way out. Make sure it's good and clean. This isn't a big deal, but having the keyway spindle notch at the top will make life a little easier when you're installing your axle nuts later. The new spindle has a pretty serious press fit, but oil always has a way of finding its way out. By coating the spindle with a light coat of good silicone, the silicone will act as a seal as well as a lubricant to help with the pressing into the spindle. Apply a small silicone ring on the shoulder of the spindle as well as on the raised section that will press into the bearing pocket. With the keyway on top, use a good-sized dead blow hammer and drive the spindle into the axle tube until it seats on the shoulder of the spindle. Slide the backing plate over the spindle in its original position. Install the spindle retainer block oriented with the part number visible on top. Use thread lock on the new longer 12mm retainer bolts. Tighten in a corner-to-corner cross pattern using a 16mm. Torque to 45 foot-pounds. Break out the welder and burn in a good plug weld into each of the 1/2-inch holes you just drilled. Reinstall the park brake cable. Coat the spindle and bearings with grease. The hub and bearings will actually be bathed in gear oil, so this coating will only be used until the gear oil can find its way into the internals of the hub. The inner bearing, seal, and tone ring are all pre-installed. Coat the outer bearing with grease, along with the bearing race, and install. We are again going to have an inner spindle bearing nut with a pin and an indexing lock washer and a jam nut. Install the inner nut with the lock pin visible. And while turning the hub, torque it to 50 foot-pounds. Then back it off a quarter of a turn or 90 degrees. Install the lock ring, making sure the pin is indexed in one of the locking ring holes. Flip the ring over if there's a pin to lock ring hole mismatch. Turn the hub knot tighter if minor adjustment is needed for the pin to line up with the washer. Ours didn't line up, so that's exactly what we did. Install the outer lock ring and torque to 180 foot-pounds. Before we install the axle flange, make sure the hubs and axle flanges are both clean and dry. Feel free to use brake clean. Clean is good. The axles are the same length and interchangeable on non-Rubicon axles. Rubicons will have a longer shaft on the right or passenger side. There's not a lot of length difference, so look close. When everything is cleaned up and ready to install, coat the wheel hub with silicone. Feel free to express yourself artistically. Use thread lock and install the axle shaft bolts. Use a 9/16 to tighten to 95 foot-pounds. Use a massive ply bar and an assistant to hold the assembly from turning, or they can be final torqued while on the ground. Just don't forget. Install the new rotor. Try not to get your greasy mitts all over it. Brake pads hate grease. These rotors are actually the same rotors that are used in TeraFlex's Big Brake rotor kit. Your axle strength and braking power has just been increased. As part of the Big Brake rotor kit, we need to install a new caliper anchor bracket. Once again, use thread lock on all the brake caliper and anchor bracket bolts. Tighten the rotor with an 18mm and torque to 55 foot-pounds. Next, reinstall the wheel speed sensor. Tighten using an 8mm. Tighten to 13 Newton meters. Whatever that is, just snug it up. Swap out the anchor bracket mounting hardware along with the disc pad retaining clips. Use brake grease on all the pad and caliper mounting points. Having that annoying squeak gone will be a blessing in your life. Mount the brake caliper. You may need to compress the piston slightly because of the thickness of the new rotor. Be sure to use thread lock and use that 13-15mm team of end wrenches to tighten. That's 26 foot-pounds for all of you that just got that new torque wrench. We are ready to refill the diffs. First off, tighten that drain plug. Now the goal here is to fill the rear diff with enough gear oil that it'll flow out into the new wheel bearings and keep them lubricated, while at the same time not getting so much oil in it that it starts to pump out through every orifice when it gets hot. This axle has a TeraFlex diff cover with 2 fill holes. The reason being is pinion angle. On a 2-door JK with 6 inches of lift, that rear pinion is going to be lifted so high that the gear oil would pour out the lower fill hole before it has enough oil to lubricate the gears. So here's the procedure to fill a rear diff. Fill the diff to the fill hole, then add another half a quart or so. We're trying to get the gear oil to flow out into the axle tubes and into the hub and bearings. By lifting one end of the axle, the oil will flow a little quicker. Let it drain there for a minute or so, then bring it back to level and add another half a quart. Lift the other end of the axle and let it drain into the hub and bearings. Check the oil level again with the axle level. There should be enough oil in the differential so that gear lube will flow out into the tube, but it only needs to be about 1/4 of an inch deep in the axle tubes. Do a test drive and let the oil level settle. Recheck the oil. If there's too much, don't be afraid to drain a little out. Excess oil will expand with heat and can make a real mess if it's pushed out through the breather. Throw on your new 8-lug prowess trophies. You can use some serious torque on those 9/16 studs, 135 foot-pounds. You are now ready to roll with the big dogs.